All right, guys, so we finally come to part 3. What is part 3? It's the actual unit test. So after doing there were 3 quizzes in this section. Again, it was quadratics, multiplying and factoring. And I did not reassign this one because it already was assigned to you a week or so ago. Excuse me there. And anyways, let's get started with the unit test. This one has 15 questions. So, guys, notice the very first one here for me is a little tricky because of the negative in front. Remember, guys, always factor that negative out. Okay? Factor it out. It just makes your factoring from there on out much easier. Okay? So does everyone agree? If I factor out this negative here, I'm left with all positives, right? This one goes away, that one goes away. Of course, the first one goes away. I literally took out the negatives, so they all become positive. Now, what we have left here, we're going to do an X on. We know 7 times 9 is 63, and we need a 24 in the middle, right? So let's see here. How are we going to make this work? Now, you may have to use your calculator, guys, but I know that 3 times 21 is 63. Okay? And 3 plus 21 is 24. So my answer right here, guys, is going to be a negative parentheses x plus 3, x plus 21. Wait a minute. There is a 7 x squared still in front. So I'm going to divide by 7 here and times by 7 there. And once I divide that by 7, I now have that, right? So the final answer is negative times 7x plus 3 times x plus 3. All right? Now, how do you get this? 3 times 21. For most of you, you're going to want to use your calculator. Just keep dividing until you find 3 times 21. And I've shown that to you many times in class, guys, so you better know how to do that. All right, let's go on to the next one. Now, this is a tricky one only because, look at the numbers, guys. This time, we're going to divide by 6. Don't just divide by 3. Divide by 6, right? The greatest common factor. So x squared times 6, of course, is 6x squared. Watch your minus. Minus 5x times 6 is minus 30x. Plus 4 times 6 is 24. Look how much easier this is the x on, guys. I need a 4 and a negative 5, right? So, how about we do 1 times 4, 4. To get the negative, though, we need them both negative. So, do you agree that negative 1 plus negative 4 is negative 5? Negative 1 times negative 4 is positive 4. So our final answer, guys, is going to be a 6, parentheses, x minus 1, x minus 4. We don't have to worry about adding the added 6 in there because we already factored it out. All right, wow, this one started out with a couple tricky ones, huh? Oh, this one should be easy. Now, guys, I need to be honest. Let me just set it up, but you can finish this on your own, right? I'm going to do x plus 1 there, x minus 6 there. You guys know how to do this one by now, right? I hope that's the case. Let me know if it's not the case. I'll gladly do it. But for now, I'm going to skip it. Now, what about this one here? They want to know which polynomials are in standard form. Guys, remember, standard form means the powers in order from highest to lowest. The constant or number is always at the end. So notice, this one has the power and then the number at the end. This one has the 2 power, the 1 power, the number at the end. This one just has a 1 power and the number at the end. All 3 of these I'm going to click or select because they're all in standard form. Okay? So this one actually, the answer was A, B, and C. Well, let's take a look at the next one. It is backwards, but you know what? We can rearrange it, could we not? Couldn't I say 49x squared plus 70x plus 25? And I'm looking at the numbers, guys. There's no GCF. Now this one, because the numbers are so big, you, of course, can use your calculator. But guys, I'm going to factor this my favorite way. Okay, you ready for this? I know it's going to be parentheses. I know 7 times 7 is 49. Don't forget the x's, of course. I know 25 is 5 times 5. And let's check our inner and outer loop. See, the 5 times 7 here, guys, is going to give me 35x. The 5 times 7x on the outer loop is going to give me 35x as well. Do you guys agree? 35 and 35 is 70. And so we have our answer. We're going to type in right here 7x plus 5. 7x plus 5. And that is a factored form of that. So again, with the bigger numbers, I just like to just do it in my head and guess and check, as you can tell. The X method is really brutal when the numbers get big, guys. So unless you want to grind it out with your calculator, you may want to practice my way. And since quite a few of you have subscribed to Novi Math, by the way, my YouTube channel, go back to factoring from like a year or so ago, because I always taught it by guessing and checking like I just demonstrated. So you may want to check that out, but that's up to you. All right, let's see what the next one is. Guys, do you agree that we're just going to set it up with a box? 3k plus 4, 9k plus 5, like that. And you guys know how to do this, I hope. Because I'm going to assume you know how to do this. And that way I can shorten the video a little bit. Okay, let's see what the next one is. Which expression is a result of factoring by taking out the great? Oh, so all they want us to do is do a GCF. Guys, 6, 3, 12. Do you agree I'm going to do a 3 GCF? I can't do a 6. See how B can't be right? And I can't even do an X. B. So that one. So the answer's got to be A, right? Do you guys agree? This one right here does not have an X in it. So let's just double check it. If I do 2x squared times 3, I do get 6x squared. If I do minus x times 3, I get minus 3x. If I do plus 4 times 3, I get 12. This is exactly what's right there. So the answer is A. So hopefully you guys can do a simple GCF like that with a number, by the way. All right, let's see what the next one is. Guys, this is a simple X factoring problem, right? We're going to do a 16 with a negative 8. Okay? That's how you're going to solve this one. So your answer is, of course, going to be 2 parentheses, x here, and then whatever number's there, go in there. Okay? If you haven't figured it out yet, by the way, isn't it just negative 4 times negative 4 is 16? And of course, negative 4 is negative 8. All right, let's see what the next one is. We have a rectangle with this area. Do you guys recognize it's the difference of 2 squares? And they told us one side's 11 minus x. Do you guys realize the other side has to be 11 minus x? Because this is a difference of 2 squares. Basically, they're telling you it's a square. It's not just a rectangle, it's a square, okay? It's 11 minus x. Oh, wait a minute. So, 11 plus x. Sorry. So, almost messed up there. Do you guys agree it's 11 plus x? So, it's really not quite a square. So, in other words, you guys agree 11 minus x times 11 plus x. If you do this, you, of course, will get your 121 minus x squared. The 11x and the minus 11x will cancel out in the middle. Bottom line, guys, it was a difference of 2 squares. I misspoke by saying it was actually a square itself. All right? It's actually a rectangle. All right, let's see what the next one is. Guys, I hope you guys can set this one up with a box. I'll leave it at that. It is a difference of 2 squareds, though, by the way. Oh, another difference of 2 squareds. Do you guys agree that right there is really 5x times 5x? And 16 is really 4 times 4. Notice there's no x in the middle. How do we get that? Because one of them's going to be a plus, the other one's going to be a minus. All right, let's see what the next one is. Guys, again, this one. Now, I'll set it up at least. Do you guys agree? We're going to do a square. And we all know that that square power means there are 2 of them. Because it actually is a square this time. So hopefully, guys, you can do the area or box problem I have set up there for you. Okay? But guys, that's basically it. It's a nice, thorough test if you think about it. It has a little bit of factoring and multiplying throughout it. Quite a few tricks along the way that you guys have to get good at. Okay? And hopefully, guys, you try this multiple times until you get a good score on it. Okay? This was the unit test, the last test of this whole section on multiplying and factoring with quadratics. So, guys, I'll see you around this week, hopefully.